Yeah, it's like
History is subjective, but the dates
Hey
things
guys,
occurred.
let's finish up this little section of lecture, finish up lab, and then we'll talk about the field experience and you guys getting the materials you need from over here on the side. I'll put these up here to remind me so I don't forget to do that at the end. Okay? The adrenal gland, we said, has two portions to it. It has a cortex and a medulla. All right, now if we take a look here, the cortex wraps around the medulla, so the cortex is on both sides. Now the cortex, if we look at it over here with the azan stain, I just realized over the break, that should be H&E here, azan over here. Copied that incorrectly, or I may have downloaded it actually from the website on these. But if we take a look within the cortex, we can make out different layers, can't we? In terms of the staining properties that are there. And indeed, the cortex has different, we have those different layers, we're gonna name them. Now, we don't really have a standard in terms of layers. You know, when layers in the skin, we call them stratum, correct? We had layers of blood vessels, we call them tunicas. Layers here within the adrenal cortex we call zonas or zones, okay? There is the zona glomerulosa, up here with the G, zona fasciculata, and zona reticularis. I remember those in order: glomerular filtration rate, okay? GFR, once again, the abbreviation for that, GFR is the abbreviation for here. Azan typically shows it very well, H&E may not. For instance, if we look up here at the cortex, I really don't distinguish between glomerulosa and fasciculata, but I can see reticularis, can't I? On the other hand, if I come down here, I can make out glomerulosa, fasciculata, and reticularis, can't I? Even on the same slide, one side here doesn't show the three zones, this one shows a little bit better, Azan shows it the best, okay? You can show with H&E, but knowing how we bought microscope slides for lab with H&E, you may or may not show the three zones very well, but you can identify them based on their location, okay, within that cortex. We'll start off with the zona glomerulosa. If we take a look at that on higher power magnification, you know, you've got the capsule right up here at the top, and little tiny thin sleeves of connective tissue coming down, but the glomerulosa is going to be fairly small cells. You look how tightly the nuclei are packed here compared to the reticularis down below. Fairly small cells, and they typically come up and form hairpin loops up here just underneath the capsule. All right, just underneath the capsule, not a real wide area. Cells tend to form hairpin loops right there. What do? These release your mineralocorticoids, with aldosterone being the most important. And of course, these are involved in the reabsorption of sodium and potassium within the kidney. All right, zona fasciculata is the largest of the zones. You can see a little bit of it right here, but we go to the next slide. In here, the capillaries, we'll see with the very last slide I've got, are draping down straight. And because they're draping down straight, you can get a little hint of the capillaries here with this azan stain. The dark staining in between here, here's a line of them right here, but they're draping down straight, like you can see this higher power magnification here, and that makes it so that you can look at that and say, yeah, I can get the idea those cells are arranged in cords. Okay? That's the best you're going to ever see cords, particularly if you look over at the image to the right. Those cords really stand out there. Now, what the cells here are larger. They can have a slight basophilia to the cytoplasm. I've never seen anybody tell me why they can have basophilia rather than such a bright pink here, because they are secreting steroid-based hormones. They produce glucocorticoids, which have a function controlling glucose within the body. Mobilization of glucose within the body maybe is a better way of describing it, with cortisol being the most potent here, and functions beyond just glucose, obviously, when we talk about cortisol. The deepest zone to talk about here is our zona reticularis, and what we see in here is reticularis, and we're seeing a little bit of the medulla down below here. This light blue down here is medulla. So once again, we look at reticularis, it's got small cells. Look how tightly those nuclei are packed together. And the cytoplasm tends to pick up the most stain compared to the other two zones here. It will accumulate lipofuscin with age. Many cells of the body do that. Talked about some neurons doing that. Here, they will tend to do that. Their capillaries there are more branching, so it doesn't have that nice cord appearance like we had in reticularis either. What do? These produce small amounts of sex hormones, particularly male hormones, and the normal function is not well defined, okay, as far as I know. We'll talk in embryology. If a female baby is overproducing it, it will have effects, okay? But not real defined in terms of why males still produce small amounts of androgens there, small amounts compared to the testes. What's the function of the small amounts produced in females from the zona reticularis of the adrenal cortex? All right, the adrenal medulla, if we take a look at it there, very large cells, and when you've got large cells, you want to think neurons again, and you would in fact be correct. If we look at this image, Dr. Olgan showed you something very similar to it. I know. If we take a look at it here, parasympathetic on one side, sympathetic on the other. Parasympathetic had the long preganglionic axons and short postganglionic. In fact, quite often these ganglia were in the wall of the organ being innervated. If we take a look at it, it doesn't come to the adrenal gland at all, does it? Okay, parasympathetic doesn't innervate the adrenal gland. If you look over at the sympathetic side, here's the adrenal gland. Trace that axon back. It never synapses, does it? This is your preganglionic fiber coming all the way, passing through a sympathetic ganglia without synapsing, so it's still preganglionic fiber coming all the way out to the adrenal medulla. Where are the postganglionic neurons? Here they are right here, but they don't have any axons. They simply release their neurotransmitter into the connective tissue surrounding the capillaries that are in here. Okay? So yeah, these are the postganglionic neurons. Can't talk about postganglionic fibers because they don't have axons. They simply release their neurotransmitter / hormone into the bloodstream. All right. Now, what do these produce? These produce the catecholamines, epinephrine, norepinephrine, that are part of that maximal fight or flight response you talk about of the sympathetic division. Okay? There's nervous system components here of that fight or flight response. There are hormonal components of it as well from the adrenal medulla, releasing the neurotransmitter / hormone into the bloodstream. Okay, now, when we talk about these, we often refer to these as chromaffin cells, a chromaffin reaction here. And basically what we are doing with this is using chromium salts in a stain. The image to the left is basically looking at the large cells of the adrenal medulla here, but over here we've used chromium ions in the stain. And what it's going to do is differentially stain those cells of the adrenal medulla that release norepinephrine from those that release epinephrine, which is here with the A. The pinkish ones are releasing norepinephrine. The epinephrine is the cells that are not picking up the chromium salts. So the chromaffin reaction just distinguishes between the two secretory types of cells we have here within the adrenal medulla. We don't have to have an antibody for their specific products in order to do so. All right, the last slide I've got here, I think I'm going to reincorporate this a little bit differently next year. I'm going to put it earlier. It's just looking at the vascularization. And it explains what some of the architecture we see. Up here within the glomerulosa is where you have those hairpin loops that will come up and come underneath here. They make the mineral corticoids. Here within the reticularis, you've got those long straight capillaries which produce those cords that we saw within the reticularis. And that's of course where you're making your glucocorticoids. Both down here within reticularis and the medulla, you once again have anastomosing branches of the capillaries, so we no longer have the cords, more clumps, so to speak. And the reticularis is where we're making androgens, and the down here within the medulla is where we're doing the catecholamines. Okay, kind of a summary slide I put at the end. I may put it at the beginning next time, because I think the vasculature, particularly with reticularis, really helps you understand what I'm looking at when I see cords with reticularis. All right, any questions?